All right, question 7. The shaded area in the graph below represents a feasible region for a linear programming problem. The maximum value of the objective function occurs at. Now, obviously, we could use the sliding line principle. Very difficult here because pain I don't have a sliding line. But we know that we can rearrange this equation here to look at the gradient of my objective function. So we know that z is equal to minus 2x minus 2y. Well, to find the gradient of the line, I'm going to replace or move the y over. Well, the 2y over to give me 2y, and I'm going to move the z over here, is equal to minus 2x minus z. Divide everything by 2 gives me y is equal to minus x minus z on 2. Now, why is that important to me? Because the gradient actually is what's important to me. So I know the gradient of my objective function is equal to minus 1. That's the gradient of my objective function. It's not z equals minus 1. So if I were to now slide this down, I'd be looking for points somewhere in there or along the lines where z equals minus 1. And as it turns out, what we actually can find out, or what we notice, simply because the intercepts are 10 and 10 and 5 and 5, is that both of those lines there have a gradient of minus 1. So both of those have a gradient of minus 1. So I suppose the question is, what are we now going to do? Well, because the question says we want the maximum value of the objective function, we then test points, right? And we need to be very, very careful here because they're trying to trick you. Because if I look at that point there, if I look at the lines BC, and any of those points along there, for example, if I take this point here of 10, 0, we know we've got that point there, 10, 0, then I know that the z, my value of my objective function along there is going to be minus 2 times x, so minus 2 times 10, minus 2 times 0, because my y value is 0. That's gone. So the points along there are all going to be minus 20, and we can check that point there as well, because it will give me exactly the same thing as minus 20. If we do the same here, with the value of 5 as x and y as 0, then what I get is my z-score is equal to negative 10. And you're going to say, yeah, well, then that means minus 20 is smaller. Because again, remember, minus 10 is actually bigger than minus 20. And so if we now look along there, the point C only, nope. Any point along the line segment BC, we've just said no. Any point along the line segment AD is the correct answer. Any point along segment AB, definitely not, and DC, definitely not. All right, so there we go. So those are objective functions. Always a great idea to be able to use the idea of the Z and rearrange it to find the gradient and then see which points lie on that gradient.